So the second key driver we are going to discuss is testing. The concept here is, well, if I have a good, robust testing phase, why should I use static analysis in the first instance? Well, there are many reasons about this to answer this question. And the very first one is that usually testing tend to focus more on functionality rather than on the structural consistency of the code. So basically, we try to focus on functionality, on usability, and we tend to overlook elements like the complexity, the cyclomatic complexity of the code, the function structure, the file relationship, and so on and so forth. So basically, this is what we can track also with the static analysis. And another important aspect is the ability to cover all the code. So the coverage of the code itself. If we think about trying to perform a 100% coverage by using testing methodologies, it's really unlikely that, if not impossible, that we will be able to do that. There are basically two aspects that let us think this. One is that it's not feasible or practical to generate test cases to cover every conceivable eventuality. And to make an example, to execute specific statements, to explore all the branches of the code, all conditions and edge cases. And it's almost impossible to have complete coverage also in case of infeasible path, dead code sections, or if I'm trying to make defensive programming, and so on and so forth. So the complexity is my enemy in this case, because it tends to grow exponentially. And obviously, so would do the number of test cases required. And on the contrary, static analysis in that case can help to potential cover all 100% of the case thanks to the automation. And especially if I try to use the data flow analysis, which models the runtime behavior of a program, it will provide me a very effective mechanism to identify different classes of problems like invariants or redundant operations, the referencing of null pointers, overflow, and so on. Moreover, the testing is expensive. We meant to say here that it depends strictly on the time that people has to invest to make testing. So if you think about a traditional cycle, there is a testing phase. I found a bug, then I have to signal this back to open a ticket of this defect, and then the developer will investigate that, and then we'll have to find a solution for that. Then we'll have to implement the fix, and then they will integrate that, and then I will make a regression. So this is a whole cycle which takes time, and obviously is expensive, and it takes is going to levitate the costs required to do that. And on the same page of this concept is the expansion of timelines and the introduction of uncertainty and risk, because obviously that cycle depends on how many defects I'm going to find in my code, and I cannot know that beforehand. So it will be something that I discover during the development of my code, and depending on how many cycles I have to perform, it will require more time, and I'm likely to slip my deadlines. Moreover, the testing phases in time are depending on how complex is my code. So if I inherit a high technical debt, so I inherit maybe incohesive or unordered code, spaghetti code, let's say, whose quality is going to require me to develop hardly to invest more time in develop use cases, test cases, and try to find all the possible coverage. And finally, exactly because it requires specific knowledge of different aspects, testing requires high skill departments. So it is unlike commonly assumed, testing is not a second class technical department, but it requires high skills and experience in order to be performed effectively. So here you can see basically a chart which reports the ranges of defect removal efficiency, which is the percentage of defects removed before release stage, for most forms of testing and of activities which are performed in order to assess software quality. As you can see, testing on its own performs quite low in the scale, assessing around 35% of efficiency, while other forms of defect assessing, like static analysis, like formal code inspection, and so on and so forth, assess in a better position. They rank in a better position. So if I have two takeaways here from what we've seen so far, they are that, as we've seen, it's better to pull the detection of defects forward from test to coding in order to benefit from the fact that the costs will be lower, and making testing more effective by striking the appropriate balance between functional and non-functional testing, maintaining more stable code bases, and use all the actions that can be used in conjunction in order to achieve good removal efficiencies.